Good morning, everybody, and welcome back. Yesterday, we were closing with profiling. And profiling is important for knowing what to optimize. But nobody cares how quickly you can calculate the wrong result, so you first have to get rid of the bugs in your program. You probably all had bugs. If you have written your own code, you probably have had bugs in them. And what do you do if you find a bug? What do you do if your program doesn't do what you want? You can stare at your code and try to figure out the mistake just from reasoning through your code. And if you're a theoretical computer scientist, that might be exactly what you do. You can add a lot of print statements. Who has added print statements to their code for debugging before? Or you can actually use a debugger. Who has used the debugger before? That's a good ratio. Who has used the debugger for Python before? Good. Python actually comes with a debugger, the Python debugger. And in its pure form, it's horrible. Nevertheless, it is always available, and it's even available from within a notebook. So if you have a code that throws an exception in a notebook, you can call the debug magic afterwards and actually enter a debugging session. And the most useful command, and the one that you'll try first probably when you get to this part in the notebook, is help. It gives you the list of commands that are available. But basically, you can check variables, manipulate variables, things that you would expect from any debugger. It is not very convenient, but at least it's possible. A much more convenient debugger, if you need to stick with the command line or a terminal, is PuDB. PuDB is an N-curses interface, and I'll show it briefly later, that basically wraps around the Python debugger. And it gives you the standards that you would expect. You see your code with lines. You can set breakpoints in your code. You can see your variables. You can inspect your variables. And one really cool feature, you can open an IPython shell, basically at the point where you set the breakpoint, and work with it to your heart's content. Everything that works in IPython works there, and you're basically at the state of your program. You can even visualize from the IPython shell. So if you have X available, you can then go and take matplotlib and visualize your array, which often can be helpful if you want to find hard to debug bugs. Remote debugging. Well, this is an HPC Python course. And that means that you might be debugging things that work just fine on your laptop because you are on Joules or PITSDINT or Summit, where the hardware is different from what your laptop provides, or simply things happen at scale. There are a couple of debuggers that can do remote debugging. PyDev, which is basically an Eclipse extension, can do remote debugging. If you're not a fan of adding a lot of Java to your Python programming, there are other options like Wing Personal or Visual Studio under Windows. Actually, Visual Studio has become a pretty good IDE. I'll get back to that later. PyCharm only offers it in the professional version, and fairly newcomer in that area is the Visual Studio Code, which also allows remote debugging. It's still in most cases not that pretty. So debugging is really the stepchild of Python. It's almost as bad as profiling. Debugging Python extensions raises the whole thing to yet another level. So debugging at the same time Python code and the C program that you wrote to make your Python code fast only works with a very few debuggers. Actually, that's not quite true. You can use PDB for the Python part and GDB for the native part. And in the end, that's kind of what all the debuggers do. But depending on how well they package it, this makes for a smooth or less smooth experience. Now, when you look at the example that I did earlier, I had this weird bug, and you'll look at it in more detail when you work through the notebook. But what I do in that code is actually do a check, a range check, by hand. And you shouldn't do that. It's better to ask for forgiveness than to ask for permission is kind of a Python philosophy. Although when we get to CUDA, I'm going to tell you exactly the opposite, because we don't have exceptions there. But here we do, and then we should take advantage of them. So the code would have been better written in this way. It would have thrown an exception when when the index would have been wrong, but we wouldn't have had this weird bug. All right. That was my very short introduction to debugging. When you get to the notebook, again, work through your parts. And when you get to the pure DB part, I'll actually show you briefly the commands that you can play around with.